When a neuron is at rest, the resting membrane potential is positive on the outside of the cell and negative on the inside of the cell. When at rest, there are 10 times more sodium ions outside the neuron than inside the neuron. These charges are maintained by the sodium-potassium pump. This pump pushes 3 sodium ions out of the neuron for every 2 potassium brought in. Negative chloride, phosphate, and sodium ions inside the cell also contribute to the negative charge on the inside of the neuron. Large, negatively charged proteins inside the neuron are too large to pass through the cell membrane and therefore stay inside the neuron. Nerve impulse starts when a stimulus reaches a dendrite. This signals action potential to start in the area of the dendrite where the stimulus has occurred. The action potential causes depolarization to occur. Sodium channels open and sodium rushes in, causing the neuron to be depolarized in that area because the charge changes to more positive on the inside and negative on the outside. Through this process, depolarization moves down the membrane. To restore resting potential, sodium channels close and potassium channels open as action potential moves down the neuron. As potassium is pumped out of the neuron, it is repolarized because the charge of the neuron goes back to negative on the inside and positive on the outside. The action potential continues down the dendrite, through the cell body, and into the axon. The myelin sheaths on the axon can block continuous flow of ions, so the action potential must jump between nodes of Ranvier. This is called saltatory conduction, which causes action potential to travel quickly down the axon. The action potential depolarizes and repolarizes the axon as it travels to the end bulb. When action potential reaches the end bulb, calcium rushes into the neuron. The presence of calcium causes fusion of synaptic vesicles with the presynaptic membrane. Neurotransmitter is then released into the synapse, and the message the neuron received in the dendrite is conducted into the next cell, which could be a neuron or a muscle cell. Through repolarization, the neuron is returned to its resting potential.